Our AC motor for the MEC-150 class, and what we have here is a transformer which takes the voltage from the wall, 120 volts, and steps it down to 12.6 volts across the end taps. This transformer has a center tap, which is seen with this black wire, and we tried to use the center tap, which would only provide 6.3 volts, but it wasn't enough voltage to have our motor run. After coming out of the transformer, we have two sets of windings that are wired in series. We have this winding and this winding are wired in series with a capacitor in series, and these two windings are wired in series but do not have the capacitor across them. And the reason for the capacitor is it splits the voltage coming from the wall, which is single phase, and creates two phases which help the motor spin on its own. Without this capacitor, there would only be one phase going through the windings, and we'd have to have some means of starting the rotor spinning once it was plugged in. So these windings were made by wrapping copper wire around bolts, and we wrapped it back and forth 8 times in order to achieve enough current and create enough induction to get the motor to spin. And once this motor is plugged in, the current in the copper wire induces a magnetic field in the bolt, which also induces a magnetic field in the lid. And since these are out of phase, the induced magnetism tries to reach the next bolt, and that's what causes this to spin and creates the torque. So if I plug this in, we'll see that the lid starts to spin slower, and once it reaches the full strength, it'll be spinning. And as this is spinning, the magnetism in the lid is trying to catch up to the magnetism in the windings, and that is called slip. And this completes the AC motor lab for MEC-150.